Okay, so welcome back, and now for the precise definition of convergent and divergent series. Okay, so in this definition we have, again, it starts out similar but changes quickly. And so we're going to use more precise language to define what we're talking about as far as a convergent sequence. Okay, so it says a sequence of a sub n converges to a real number L if for a epsilon greater than 0, or for some epsilon greater than 0, for all, that should be all. That didn't look right. For all epsilon greater than 0, there exists an integer n such that the absolute value of the difference between a sub n and L is less than epsilon if n is greater than or equal to n. The number L is the limit of the sequence, and we write the limit as n approaches infinity of a sub n equals L. So the nth term. So we're talking about the nth term here. Okay? So if the nth term approaches L, and what do we mean? Well, it converges to the number L if for all epsilon, so for some value that we choose that's greater than 0, some positive value of epsilon, then there exists some n. So if we can find an n such that this absolute value, this distance, so the distance from a to n L is less than epsilon if n is greater than or equal to n. Okay? So we can get as close as we want to L. Right? So what we're saying is, hey, if we get sufficiently close to L, let's say within epsilon, some positive epsilon, then as long as there's some value of n that we can choose, that as long as the index is greater than or equal to that value, then we're going to be guaranteed that we're going to be within epsilon of this limit L. And if that's the case, if that's true for all epsilon, no matter how small we make it, then we would say that L is the limit of the sequence. And we would write the limit as n approaches infinity of the nth term equals L, or we would say that a sub n, the nth term, approaches L. Now, in this case, we say that the sequence is a convergent sequence, right? Okay? If a sequence does not converge, then obviously we call it a divergent sequence, and we also would say that the limit does not exist. Okay? So if the sequence is convergent, if it's a convergent sequence, then it has a limit, right? The limit exists and we can find it. If it's not convergent, then the limit does not exist. Okay. So let me show you what I mean by this definition. Okay, so what we can say is, let's say we have something like this. And so this is going to be n, right? And this is going to be, let's say we have L on here. Let's say L. And let's say we have, let's say we choose an epsilon, okay? Let's say we choose some epsilon greater than 0. Let's say we choose, and we do a distance epsilon. So this would be L plus epsilon, and this would be L minus epsilon. And so what do we get? We get this little band, right? Okay, so we have this band, right? So this is right what the definition is telling us. Okay, we're saying that, hey, for all epsilon, for any epsilon greater than 0, in other words, we can create this band, this neighborhood around L. And if there exists some n, right? So let's say there exists some n, let's say there, and so let's say we've got this sequence of numbers, right? Right, like so. And let's say we've got here, let me do this. Okay, so there's our line for L. Okay. Okay, so here's what it's saying, right? So it's saying that for all epsilon greater than 0, there exists some number n, right? Some integer n, such that the distance from L to epsilon, the distance from L and a sub n, right? So a sub n is the value of the nth term of the sequence. So that's represented by these purple dots. And what we're saying is that the distance from L to the nth term, whatever the nth term is going to be less than epsilon. Okay, so in other words, it's going to be within this band. Okay, so the distance between, and here, let me just show you. So this distance here is epsilon, right? So within this band, for all n greater than this. So basically, we could say that we have a convergent series if for any epsilon greater than 0, that there exists some n such that for all n greater than or equal to this value, all of the points, all of the nth terms will be within this band, and they get closer and closer to L. Okay, and so this is a graphical display of what the definition is telling us. Okay, so let's go do some examples and take a closer look at this.